should still be $0, not 0, 0, or something like that. Then if I input a 1, then if I input a 2, that should hopefully yield me 12. So in short, this is finally the opportunity whereby we might have always, especially in 50, preached like think about corner cases and test zeros and negative ones. You can literally now make those tests yourself so that you know with confidence at least your code is correct with respect to the framework you yourself have written. Yeah?
So if we have this test digit, why do we also assert in the other methods that the label is still 12?
Good question. So if we're testing one thing here, why did we seem to be redundantly testing it elsewhere? You don't have to do it that way. And in fact, there's this notion in unit testing called mock objects. And the idea is that you really try to test only the method in question. So I'm kind of being a little lazy here in that I'm testing the deposit button as well as the key presses in one place. And a mock object would essentially mean that you actually implement a fake version of the digit method or of the clear method so that you know that its value is just always going to be some sentinel value. But because these are relatively simple programs, and I think in terms of learning the stuff, I think it's a little easier to just write more intuitive tests. But ultimately, we would not want to test multiple methods in the same test routine generally, if that makes sense. All right. So, and then teardown, this is commented out. I actually don't need to do any teardown because I haven't done anything interesting. So we can essentially leave it at that. So when I actually choose then my application test and I click run here, not run, click test for this target, notice that it builds, succeeded. Notice that the simulator pops up, immediately quits, but that's good because the test succeeded. And if I actually do something wrong, let's go up to test clear. And let's say deposit should be 1. Well, let's actually change this to like 1,000, which is definitely wrong. So now let's rerun the tests. The simulator should pop up again after the build succeeds. Ooh, test failed. And I now immediately see which line of code failed some test. And I can now try to hone in on what the mistake actually was. Yeah? It's a good question. I believe, it's a good question. I don't know. I suspect there is no guarantee that they will be executed in order because they should all by design be independent. But it will always be setup, method, teardown, setup, method, teardown. Yeah?
Once one of the tests fails, will it go to another one at all? Or do we, like if we say we corrected that, do we have to worry that another test might fail after that? Or does that imply that all the other ones are fine?
Good question. So in this case, I've just made 2 mistakes in test clear and test deposit. The assert will kill execution of the code where it fails, but the subsequent methods will still get called. Which is why, again, the upside of writing unit tests, especially if it feels tedious, the motivation is keep them nice and small so that they're really testing individual things. Other questions? All right. So some words on evil hangman, and so that we have an opportunity to discuss some possible design issues. I'm scrolling down here in the spec, to the various features and design constraints, just to strike up a conversation as you submit or start your alpha for tomorrow, what kinds of things you want to be thinking about. So ultimately, your application has to do a few things. When it starts up, you have to load the dictionary of words from the plist, and then what needs to happen next? What kind of UI elements do you need on the screen? Okay. What's that? Okay, so a label for what?
For having your guesses.
Okay, so for the guesses, so I'll just draw that as a rectangle, but assume that the UI, the aesthetics can be whatever you want. So this is this is a UI text field. What else do we need on the screen?
Do we need the keyboard to be there for input?
Okay, so we need some kind of keyboard. So I'll just depict this with some keys like that. What else do we need?
A label to display the word.
Yes. So we need a label to display the word. Okay, so word and guesses. So let's assume that this is, there's 2 things here. So one is the word that you're trying to guess. So I'm going to draw it just as placeholders, but you can do it any way you want. And then maybe we do need another label to show the letters of the alphabet that you've guessed or not guessed. Some kind of feedback mechanism. What else might we need? Yeah?
How many guesses do you have left?
Yeah, so how many guesses do we have left? So we need some kind of label or some kind of UI mechanism. As I showed last week, I chose to use a UI progress view just because I thought it looked a little sexier than a number, but you can do whatever you want. But another UI widget here. Anything else?
A button to change the settings.
A button to change the settings. OK, so if you follow the template of the utility application, could be something over here where this is settings, and that'll flip things around. You can still use the little I in the bottom right-hand corner, but if you're using the built-in keyboard, it's going to be a little hard to access that, so you should at least move it or change the functionality to be this button. Yeah?
I was going to ask if it was OK just to use the I.
Good question. Yep, absolutely. You can just use the I if you want. Yeah? What's that? Yeah, so we need another button to start a new game. And realize I'm a little biased here. I'm essentially drawing my version of this. But you can do this. Any interpretation is fine. All right, so that's pretty good. So some of the design considerations. One came up before class and on the help boards last night. You've got 140,000 words in this dictionary. And one of the constraints in the spec is that the user should be able to choose word lengths between 1 and the maximum length of the words in the dictionary. So do you hard code this? Maximum, N, we call it in the spec. What are the options here? You can hard code it by skimming through the list or writing a little script that finds the longest word or sorting them by length and then just counting the letters manually and then hard coding that with the sharp define or a const. That's one approach. What's an upside of that? It's fast. It's correct. The spec only requires that you support words.plist. So in theory, the dictionary is invariant. But downsides? It could change, right? Like, for the spec, we only require words.plist. But does it feel like the best design to hard code that? And then anytime you update the dictionary with every update to your app store, like, it rubs me the wrong way, right? Feels like we might as well figure this out dynamically so that we're not introducing a potential mistake. And frankly, on a gigahertz whatever device, like, you can search 140,000 words pretty fast and figure out the maximum length. So I would encourage you, from my own design perspective, just figure it out dynamically probably, unless you find that it's crazy slow. But I don't think you'll find that to be the case. But again, argue it one way or the other in your design document or in comments in your code if you disagree. So what about this, the keyboard? So some people don't really like the built-in keyboard. Why? Yeah.
All the keys are still there even if you guess the letter.
Yeah, there's all the keys that are still there. Even if you guess the letter, all the numbers are there, all the punctuation's there, the space is there, the return key is there. There's just way more than the 26 buttons you actually need. Now on the upside, what's an upside of actually using the built-in keyboard? You don't have to make a keyboard, right? It's a wheel you don't have to reinvent. Downside, though, is that same reason. And unfortunately, you can't override, at least via any public API, the colorings of the keyboard of individual letters. So you can't sort of do what would be ideal, probably, which is disable some of the buttons or change them aesthetically and hide other numbers and whatnot. You can install a different keyboard altogether. You can have all numbers. You can have email address-centric keyboards and whatnot. But you don't have fine-grained control via the SDK. So what's an alternative to using the built-in? What's that? Make your own. All right, so that's not that hard, right? You just need, it's a little tedious, but you need 26 buttons probably, or 26 something so that you can detect where the user is actually pressing. So if you have 26 buttons, you probably need 26 IB outlets so that you can talk to each individual button so you know what letter was pressed. So you could have 26 properties, each of which is IB outlet, but here you're starting to cross that line of reasonable design, right? 26 properties is sort of CS 101 style, like let me just have 26 variables. What did we do once we had 26 variables? Collapse them into an array. So now maybe you have an NS array that's a property, but the array can't be an IB outlet. You can't just drag multiple things into an array. Just Xcode won't let you do that. But remember from our no-nib example in class a week or two ago, you can programmatically create the effect of those blue lines by adding targets. You can configure things with code to listen for messages. So that might be one approach. Now, it's a good way, frankly, of dividing work. If you really hate the keyboard, have your partner make a new keyboard while you focus on the models or something. So it's one way. All right, so that's one approach. There's no right answers here. So what are some of the other design decisions? Well, when it comes to actually implementing good gameplay, so non-evil hangman, what needs to happen in verbal pseudocode when the game starts up? Yeah. Okay, gameplay picks a word. You store that in some local or some instance variable or some property, probably, in your good gameplay object.
And as the user guesses, it displays the letters or whatnot, or penalizes you with taking a guess.
OK, good. So as the user touches numbers on the key or UI buttons that you've manually constructed, you need to start revealing letters or penalizing the user if they've guessed a letter that's not actually there. So good gameplay is actually relatively easy to implement. And I would probably recommend starting with good gameplay. But we have to bear in mind that you also need evil gameplay. So you need to somehow, ideally, standardize the interface to these good gameplay and these evil gameplay objects. And the spec specifically has you implement a gameplay delegate protocol. So those of you who are quite comfortable with object-oriented programming probably realize you can actually have a parent class and then have both evil and good descend from it. So you could standardize the interface that way. And that's fine. We do prescribe intentionally a protocol just because